can we say this? 3 share 2, okay? 2 is fair. 3 share 1 between 2. 3 share 1 between 2. 1, 2, 3. These two share this 1. 3. 3 share 1. When you have 3, you share 1, right? When you have 3 items, okay? You're an item, somebody else is an item, and something to share. Just think about it. Think about it. Another thing I wanted to put into this is a design. Is one of my designs is that if I have a dice cube, right, or anything, and I open up the sides, but I open up the sides with this number, leaving 2, 5, 8, and the reverse after 2, 5, 8 would say 5, 2. So I would go 2, 5, 2, 5, 8, 5, 2, 5, 8, 5, or with the next number in line would be going 2, 5, 8, 5, 2, or it would be 2, 5, 8. Well, in roulette, it goes 2, 5, 8, 2, 5, 8 again. So I put it this way, 2, 5, 8. Now, 5 is the center of the cross. To the left of it is 4. To the right of it is 6. Above it is 2. Below it is 8. So if I flip the next side onto this side, right, this would be the bottom to the 5. This would be the side to the 6. 2 and 8 would face each other. 2 and 8 face each other. 2 and 5 come together. 4 and 6 versus each other. Now I bring these to numerological values. 2 and 5 equals to 10 and 7 and 3. 2 minus 5. Which equals to a total of 20. Now, I'm not going to do the minuses, but what I like to do now is because I like to take the multiplication plus the 7, right, and 5 minus the 2, right, would actually be the 3. So 5 plus 2 equals to 7. 7 minus 10, 7 plus 10, 3 plus, and 3 minus equals to 17, equals to 7, equals to 3, and equals to 13. These are its numbers to start. So let's continue. We have the total here. It took 1, 10 plus 7 plus 3 is 20. We have it 10, 10, and 10. Why 10? Why am I doing it this way? Why am I using the multiplication? The multiplication is used because of this. Okay, this is the multiplication. Here it is in 1 square. Here it is when we use 4 squares. Hold on a second. Here it is when we use 4 squares. There is a difference between 1 and 4. Inside of 4, you get a center, and it is division between lines. In between here, it is the heart. It is the heart of one area complete. Okay? So take it the way it is. In here, we get the ace or double aces or quadruple aces, right? One has my back. I'm going this way. See the beak? Just put a little eye over here. We got a beak. So now we go 3 times, so that's 30. Well, it's 4 times, so that's 40. 7, I'm going to add these now. 10, I get 20. 40, 20. 17, 24, 25, 26, 27, 37, 38, 39, 40. 4, 2, 4. It'll also say 787 at the end. The gateway, 15. It'll all equal to 6, 68, 68. This is what this is. The second part of this design is if you've designed it once, all designs have to fit. How will they fit? How will they fit? And why do we have to do it? I don't know. I just know that ever since I started this project, everything seems to have to fit. Right? Everything seems to join together in holy matrimony to keep creating. Now, I'm not sure what I would have to put over here yet. I know there's 1, 2, 3 spaces, right? And here's 1, 2, 3 spaces. I'd have 1, 2, but the third space, I have an arm coming out here. 1, 2, 3 spaces, right? 1, 2, and the third space is the arm. The third space is the arm. The 2 arms have to lock. So I would have to actually put over here this one over here. And then this one would have to come all the way down over here. And they'll just keep connecting. And these numbers will be put everywhere. and then we'll fold this whole thing in. Do you see the X with the extended arm, the X with the extended legs? All these designs, see the X with the extended leg? Here's the X. And these are all on the skulls because these are all on inside lines because I'm using the 4 box where the center line is in between. This is what happens. It's an obligation. Step number 1. Let's not do any more math over here. We're going to go backwards to another page and we're going to do anybody. We started off with this box. We have to understand what boxes do. Here, I have 4, 4, 4, and 4. So everything is online. And when I draw it online. The second one will complete the box, 4, 8, 12, 16, all online. This one needs to be shared because the only way to create this is to open this up, and this one is shared by all. Do you understand? I'm in between. I'm one away from everything. But when you're one away from everything, you are large over here and you are large over here. I'm not sure what squeezes in. I'm not sure what squeezes in, but I will show you over here. Here is a single square in the center. I created the top part and the bottom part, right? The bottom part. That automatically creates the tunnel. And I put an N, but I didn't put that N. I put a small N by just putting a line connecting 2 sides. I connected 2 sides on the slide. You know, if you can do this, if you can do this every 10 feet, if you can do this every 10 feet, then you can slide down a building. You drop to here, you drop to here, you drop to here. You can go 1,000 feet falling. Look, I fell down. Big deal. So over here, you get what it is, the N effect. So the first N goes in the box. The second N, okay, and you have to remember, we must always reach the bottom of this area over here, the bottom of the center square to begin with. So the next N would start at the bottom, it would go down, and it would reach the top. It would only be over here. So we have the first N with 1 box. We have the second N1, N2 will now take 4. Now we need to go to N3, and this one is up over here. So we go all the way to the top. Do you know what I'm saying? I went to the middle of the box here with this one. I go all the way up, I get to the middle of the box, and I go up. Then I take it and I do it from this side, the same thing. I take it from here, I go all the way up to this side of the box. See, this one went to this side of the box. This one will go to that side of the box, and they'll both own this area space. They'll both chop away the 2 area spaces, and it will go all the way down, and then you connect the design together. Now, you know, you connect this design together. I'm trying to think what it's supposed to actually do. Okay, you connect this design together, and then these are the 2 sides. Here's one side, 1 area, 2 areas, 3 areas, 4 areas. This is the center block. You see the way it's standing up in between? And this is the creation of the ends. The end that went from this level here to this level here. I didn't move up to the top level, and I brought it down 1 level because I needed to get this corner. Okay, this one goes up in top left. This one goes to bottom right. It goes through the top and it goes through the bottom. 1, 4, 7 out in 3, 6, 9, crossing over 2, 5, and 8. And these are all the obligations. In this scenario, okay, using the 4 block, using everyone in the floor block, saying 1 area equals to 4. Now, why is that? Now, you can look at it many ways. Anything on the line, right? Anything on the line is a separation area. That means we have to shove in another row of numbers. So this is actually 9 points of distance and 1 in the center. 1, 2, 3, 4, 5, 6, 7, 8. There are 9 points of difference. And there are 9 points of reference centers, 1 in the center of each, and there are 4 points of reference centers in the center of each square. So this square, right, is 4. This square is 4. The total area of shared space, this center space, is 1, 2. Shared share is 4. This area is 2. This area is 2, and this area is 1. 2, 1, 2. And we do this in all the corners. So it becomes 4 with 2, 1, 2, 4, 2, 1, 2, 4, 2, 1, 2, 4, 2, 1, 2. And this is all the area of personal space. This is a personal space of 4 squares. A, B, C, D. 4 squares. Here is 2 squares. Okay? Here is 2 squares. I don't know what you want to call them. Call them E, F. And then you have G, H,
and then you have I in the corner. Actually, it's A, B, C, D, A, B, C, D, E, F, G, H, I, if you want to look at it that way. So I would meet in all four sections. I would be in the corner in the center box. 4 by 9, 36, Roman numerals 4, if you revert it. 1 revert 9 equals to 10. So this center meets at 40. And you have the same thing. Then you have this area of box to contend with. This area box, okay, is now 1, 2, 3, 4, 4, 8, 12 is now 16 blocks. Where this one was 9 blocks. This is what area space does, whether you're using this one or whether you're using this one. It is in this one, okay? If I create this, okay, with a single block of 9, then I have used this one here. 1 set, 2 sets, 3 sets, 4 sets. But if I separate it, like this one here, this one here, this one here, the different separations starting with no center block, starting with a center block, starting with no center block, this is a 4. If this was a 4, then this actual area, the first end, would actually be over here. And then I would just repeat a box over here, right? And then it would look like this. And then again, we would attach the designs together. So now we know what we have over here. So in this part over here, I have, this is F, this is G, this is F, this is E, this is E, this is, this is H, this is H, this is H, this is F, F, this is E. So you have 4 times E equals 20. And actual, right, part of this square, one of these squares are already here. This square plugs into the game. The first square plugs into the game. You don't have 3 of these letters. You don't have these letters. A, B, I think it would be C also, A, B, and ABD. ABD, I'm not sure if those are the exact ones, but 3 of these squares have to be added on to this game. Or is it 4 of them? I'm not really sure how many it is. 3 or 4 blocks come into the game. And it plugs in. You see this X over here? It plugs in. You had a 4 area to start. You plugged in a 3 area or another 4 area. You plugged in. Let me see this. 1, 2, 3, 4. 1, 2, 3, 4, 5. Yes, you had a 4 area to start. You plug a 5 area in. 5, 4 equals the DNA of the IT suit system of the sun. Plugging up, building the pyramid, putting on points. Each one of these are energy. Now, my question is, do we add on 3 or do I add on 5? Is it a 3-5 corner? Because there's a single block over here, each row, right? I can just add on block of 2 and a block of 2 and a block of 1. 2 and 1 and 2 and 1. Or does this one hold the whole corner? So I don't really know that answer. All I know is it gives me this number. It shows me 5 and 4. But, like we all know, it shows 2, 7, 1, 8, 5, 4, 3, 6. So they're all telling a story. Whichever one we put is wherever the birth circuit comes from. So that's what we have over here. This over here I connect. And when this connects over here, in roulette, the actual vision of this is this. In the roulette, it shows you, let me see, did I design it right? Straight up here. No, roulette is, hold on a second. Roulette is this. Yes, that's roulette. Hold on a second. Hold on a second. I don't like to have the shadow. Yeah, roulette is basically like this. Like this, exactly like this. See the way it becomes in dimension? And this is the way I see it on the roulette table. The numbers on the roulette table over here will be 10 and 13. Okay, it'll be 8 and 11 that will come together, and then 8 and 11 will come together, and it'll create, 8 and 11 is over here. How do I do this? This way, it's this way, right? It's not exactly this design. I can't exactly, but this is the design of it. And it's 10, 13 equals to 23, and 8 and 11 equals to 19. So you have 0, 4, 42. And look at that dimension.